So you're going to want to have a periodic table handy. And then there was this list that's available on our homepage that just has practice problems for us to do. If you haven't done those, go ahead and start doing those. And then if you have the periodic table that either I sent and you have my version, or you made your own version with colors to indicate charge states, that'd be great. All righty. Any questions before we get started? So we're starting nomenclature, and nomenclature seems like it's not that hard, but it's one of those things that just takes a lot of practice. And so if you're probably not yet feeling discouraged, but when that moment comes, because everybody's going to feel a little discouraged in nomenclature, like, why is this so hard? Am I not getting this? Just know that you will with practice. This is one of those things that anybody can learn. It's just work. But some students aren't used to working for their learning, which is both good and bad. And so it can be frustrating sometimes. So today's Thursday. And there's a practice page that I'm just going to work through. Sometimes it's helpful just to see, you should try to do the problems yourself beforehand. That's always good. And then to see somebody walk through the answers so that you can see what your correct thinking is, and then also what things you didn't think about in the right way. And so there's this practice page for us to do. Some of you are unmuted. Well, that's nice. Now you can talk.
Hello.
I won't be peer pressured, Sue. You can't make me talk. Hello, James. You're not the boss of me.
Okay. I'll stay unmuted, but I don't have anything to say.
Okay. Well, the reason you would want to mute is sometimes people, when they wrestle their papers, like the camera highlights them. If you don't necessarily want to be caught on the videos. I understand why people mute. I'm just saying. Okay. So the first one, so we have to go from formula, from name to formula and formula to name, and everybody has a favorite direction. And once you figure out, maybe tonight, what your favorite direction is, that just means you need to practice the other direction more. You need to practice them both, but you want to work on your weaknesses more. So the first one is sodium sulfide. Now there's some words I'm going to say that may seem silly right now, because like literally all we're doing is ionic nomenclature with monatomic ions. We look at the periodic table to decide what the charge is, and then we put them together in a way that the compound adds to zero. So some of the words I'm saying, you might think, well, yeah, duh. But I know where we're headed, and I know that later we're going to have to say these same sentences to ourselves when it gets more confusing. So I start by saying, that first word, is that a metal? Yes, sodium is a metal. So that tells me that this is an ionic compound. It starts with a cation. And then I look at my periodic table and find sodium, and it's in group 1, which means it's going to lose 1 electron to become isoelectronic with neon. So we have sodium ions in this formula. The second word, sulfide, has to be a nonmetal. The second one always is a nonmetal or group of nonmetals. And then I find sulfur on the periodic table. Here it is. How many electrons would sulfur gain to be isoelectronic with argon? It's in group 6, and it wants to be like something in group 8, so it needs to gain 2. So the anion has a 2- charge. And then I put them together in a ratio where the charges add to 0. So I'm going to need 2 sodiums. And I show that with my subscript, and that is sodium sulfide. At any point, if you have questions, please ask. And if your question is a little bit embarrassing, you're like, why this? Even though I think everybody probably knows but me, they don't know. Just ask anyway. It'll help all of us. Okay, that was the first one. The next one is barium fluoride. The first thing we do is look at this thing and decide, is that an element or a compound? It's a compound. There's more than one thing from the periodic table here. Is that compound ionic? Yes, it is. How do I know? Because it starts with barium. If the first word is a metal, that tells us this is an ionic compound. So I find barium on the periodic table. Barium is in group 2. Metals in group 2 lose 2 electrons to become cations, and this one becomes isoelectronic with xenon. What that means is it's going to have the same number and arrangement of electrons in the ground state. Don't worry about that sentence. That was my fine print. So it's in group 2, it forms a +2 ion. And then fluoride is a halogen. Here's fluorine. It's in group 7. How many electrons does it need to be like something in group 8? It just needs to gain 1. And fluoride is isoelectronic with neon. It has the same number of electrons, which makes it super stable. I need to put them together in a ratio where they add to 0, and so this is barium fluoride. You might notice things like, I'm not showing the charges in the compound. That's right. Even though that compound is made from ions and ions have charge, we don't show those when they're in mixed company. When we're all mixed together, cations and anions, we hide our charges. Okay, the next one is tin 4 oxide. So what does this 4 mean? That is the charge on the tin ion. Why did we have to state 4? You know, we didn't say sodium 1 or barium 2. And the answer is because tin has more than one possible charge choice. So tin is a metal. And it's a metal in group 4. And so it could lose 4 electrons to become more stable. But it also can lose 2 electrons to become stable. So there's 2 charge possibilities for tin. It could be a +4 ion, or it could be a +2 ion. There's a third charge choice, which is neutral. And neutral just means it's an atom. A neutral species, if it's an element, is an atom. And an atom is neutral because it has the equal amount of protons and electrons. Okay, so it is possible for tin to be neutral. Tin is element number, I can't see it, but I think it's 50, and it has 50 protons, plus 50 charge in the nucleus, some neutrons, depends on the isotope, but neutrons are neutral. And the atom has 50 electrons, and that's why it's neutral, is because it adds to 0. But, so that is a possibility. When it has an even number, and we call it, now it's a charged species, and we call it an ion, the choices are 2 and 4. That's why it says tin 4. And then here's oxide. Oxide is a nonmetal. It's a nonmetal in group 6. Things in group 6 need to gain 2 electrons to have 8 in the outer shell, which is also known as the valence shell. So to be isoelectronic with neon, oxygen needs to gain 2. And if you gain something negative, you become more negative. So we're going to need 2 oxides to balance that +4 charge. And there's the formula for tin 4 oxide. The next one is copper 1 phosphide. Phosphide doesn't sound right, does it? I think phosphate sounds right. Yeah, phosphide doesn't sound right. So this is going to bring up an important point for you and you all as you learn this nomenclature system of naming things. Sometimes it doesn't sound right. We're going to get to the place where we're going to have to write the formula for chloric acid, and it feels like, oh, chloric acid. You mean hydrochloric acid, right? And the answer is they're both real things. And so I want to emphasize this point right now. We haven't learned about phosphate yet. Phosphate is a polyatomic ion. It has oxygen, that's why it ends in 8. And phosphite, like phosphate, has a -3 charge, but it has 1 oxygen fewer. So we haven't learned about 8s and ides yet, but those are other anions that are possible. What we're focusing on today are the ides. And the ides are atoms that have gained electrons to become more stable. So here's phosphorus. Phosphorus is in group 5. It has 15 protons, or it wouldn't be phosphorus. Some neutrons, depends on the isotope. And then it has 15 electrons. That's phosphorus, the atom, but it's not stable that way. And so phosphorus gains electrons. How many electrons? Well, if it could be like argon, things in this group, the noble gases are also called the inert gases. Inert is a fancy word that just means unreactive. Why are they unreactive? Because they are so stable. Why are they so stable? Because they have the perfect number of electrons. So if phosphorus could gain 3 electrons and have 18, like argon, it would have a minus 18 charge around the nucleus, and that adds up to a minus 3 charge overall. 15 minus 18 is 3. So phosphide, which sounds wrong, has a minus 3 charge. No oxygens. There is something called phosphate, but we haven't learned it yet. Maybe you've learned it. We haven't talked about it in this class yet. Okay, so again, copper 1. Copper is an atom that can have more than one charge choice. It could be neutral, or it could be copper 1 or copper 2. And so because it has more than one charge choice, we have to state which particular ion we're dealing with. So I need this to add up to 0. How about 3 plus 1s? We'll make plus 3 for the cations, and 1 minus 3 makes minus 3 for the anions. Copper 1, phosphide. Okay, so this is a compound. I know it's a compound because it has both zinc and nitrogen in it, 2 different kinds of elements. And I know it's an ionic compound because zinc is a metal. And I need to know what the charge on zinc is. So I go to my periodic table and I find zinc. There's zinc. Uh-oh. Zinc's in the unknown zone. This is where there are variable charge possibilities. But I did talk about this in a previous Zoom, and it's also on a video that you're supposed to watch. Let me jump over there real quick. And then I gave you, here's the video that you can watch, or you can watch the Zoom that was yesterday's, or here's a periodic table that I want to talk about for a minute. So I've made this periodic table, and if we were in class, we would spend time in lab, everybody would make one. And we would focus on the fact that things in group 1 are yellow. And I have down here my key, I've said yellow means plus 1, because alkali metals lose an electron to be more stable, to be like the inert gases. And then things in group 2 are orange, because on my periodic table, I've said orange means plus 2 as the charge, which makes a stable ion. And so I've got this key here that talks about cations and anions. And then some of these, 1, 2, 3, 4, 5, 6, 7, those 7 have 2 possibilities, which gives us the chance to have some Latin names. But just know that everything in this area, the transition metal area, which is here and also down here. I don't know, can you see my little plus sign moving?
Yep.
Okay, good. So all of those have variable charges. We just don't, some of them have more than 2, and so we don't have them colored with 2 colors. But manganese has a lot of charge possibilities. So we have to state the charge on manganese if it's in an ionic compound. So just because they're not colored on this table doesn't mean we don't have to state the charge. But look at these 3. Here's silver, element 47, cadmium 48, zinc 30. These ones are exceptions because they're in the unknown zone, a place where there should be more than one charge choice. And yet silver can only be plus 1, it's yellow. And zinc and cadmium can only be plus 2. if they exist as ions. Of course, they can exist as atoms, and then their charge is 0 because atoms are neutral. So I just want to point out that silver, cadmium, and zinc, we don't state the charges because there is only one charge possibility. Okay, and then there's this packet, which if you weren't here yesterday and you haven't watched that Zoom, you haven't seen this, but here it is. It gives us a chance to practice making formulas, the compounds, and then writing the names of compounds, and there are keys there. The 7 that are highlighted on the periodic table that I have colored 2 colors is because there's a Latin way of looking at them. So iron, for example, can be, can be iron 2 or iron 3. Iron 2 and iron 3 are the 2 charge choices possible for iron. If you have a vitamin, multivitamin tablet, you might look on the label to see what's in that. And one of the things in it will be ferrous sulfate. And so ferrous could be also called iron 2. Iron 2 sulfate is a nutrient that you need in your hemoglobin. Iron 2, not the sulfate. So, but there is a system of naming. When the charge choices are limited to just 2, we use this us and ik endings. And so that's why those have been highlighted on that periodic table. At this point, you should be able to work through, what page is this? Whatever page this is. Talks about Latin endings, you can read that page. Everything up into that is fair game at this point. So there are variable charge possibilities, but here is zinc, and it doesn't have variable possibilities. Zinc can only be +2. Cadmium can only be +2. Silver, as an ion, can only be +1. And they kind of make this little stair-step case because things in group 3 would be +3. You can think of it this way. 1 step, 2 step, 3 steps, +1, +2, +3, if that helps. Okay, so for zinc, I just have to know that I've memorized it's +2. Nitride is nitrogen that has gained electrons. The "ide" happened when it gained 3 electrons to become isoelectronic with neon. So I need to shoot for the lowest common multiple, and I'm gonna, 2 and 3, I'm gonna shoot for 6. Let me have enough zinc ions to have +6 charge and enough nitrides to have -6 charge. So 3 zinc ions plus 2 nitrides makes zinc nitride. We don't have to say anything about the number of the atoms because anybody with an understanding of the periodic table can sort that out. I have a compound, cadmium and chlorine. Cadmium's a metal, so this is an ionic compound. Let me find cadmium on the periodic table. Oh, look, there it is in the unknown zone, but it has only, it's an exception. It has only one charge choice. And then chloride is a halogen, and halogens gain electrons to become halides with a -1 charge. So we'll need 2 of those. Here is cadmium chloride. Okay, in your hearts, I know you're saying this. It's because the charge is +2, and that's exactly right. Lead 2 has a charge of +2. Well, that's a little weird because lead isn't in the unknown zone. What's going on there? These are 2 other exceptions. So tin and lead have 2 charge possibilities. Tin and lead can be +4 or +2. There are reasons for that we will explore this semester, and hopefully it'll make it make more sense. But for now, we just need to know that the choices for lead are 0, 2, and 4. That's why we have to state which one we're talking about. So lead and tin are two exceptions because they are main group or representative metals, but they still have more than one charge choice. And that's why we state it. And then sulfide is sulfur with 2 extra electrons. And they come together in a 1-to-1 ratio. So lead 2 sulfide has no 2's in the formula because the 2 is referring to the charge in the metal ion. Magnesium bromide. Magnesium is an alkaline earth metal. It is a group 2 metal. What do you think the charge on it is? Bromine is a halogen, and when we call it bromide, it's become a halide. Something in group 7 has gained 1 electron. Silver is one of those that you just have to memorize. Silver, element 47, find it on your periodic table. It's an exception because even though it's in the transition metal area, it has a fixed charge as an ion. What charge is that?
+1.
Good. And then chloride is element 35 needed to gain an electron to become element 36, or not become element 36. It still has
A
the same
negative charge.
Yeah, same number of protons, but to have the same number of electrons. Oops. Iron 3 oxide. What does the 3 stand for?
The charge.
Mm-hmm. What charge does oxide have? It's in group 6.
-2.
Perfect. So our lowest common multiple is going to be
6.
Mm-hmm. When we see this, we recognize it's a compound because there's more than one capital. We know it's ionic because iron is a metal. We don't know which iron. It could be iron 2 or iron 3. So we have to take it apart and look at what it's paired with. It is not paired with bromine. So it is either iron 2 or iron 3, because those are the 2 possibilities in this compound. And bromine is neutral. There's no reason they would stick together. Opposites attract, positives like negatives, so it must be bromide, and there's 2 of them. It's a compound. There's more than one capital. It's ionic because zinc is a metal. Zinc is element number 30. What's the charge on that zinc? Do we need to state it?
+2.
Do we say zinc 2?
No,
No, why not?
because it's only available to have the 1 positive 2 charge. There's no other options.
Exactly. If I wrote silver 1 chloride, would that be wrong?
Yes.
That would be wrong. Yes. We don't deal with BE very often, element number 4. So it could be a spelling challenge. Does spelling count? Oh, you bet. It's in group 2, it forms a +2 ion. And then phosphorus gains 3 electrons, so we have +6 -6. And I know phosphide sounds wrong, but If there's no oxygens, it's an ide. It's not an 8 or an ite. Nitride probably also sounds wrong. What sounds better than nitride?
Nitrate.
That was great, of course. Yeah, nitrate is a thing. It's a tasty thing. Nitrates, nitrites, in your processed meats. Mmm. But this is nitride, and the ide means this non-metal gained electrons. There's no oxygens. Like that is a real thing. But you see how when you break the metal off, you have a chunk that has oxygen?
Right.
It's having the oxygen that changes the name to 8 or ite.
Okay.
Yeah. So here I have aluminum oxide and iron oxide, and one of these names is wrong.
For iron, we need to clarify that it's iron 2, right?
You need to clarify what the charge is. That's exactly right.
Yeah.
How come?
If you don't clarify, then you don't know.
Because there's more than one possibility. That's right.
Isn't it iron 3 though, because the charges are reversed? Because you said you have to break it down, right?
Uh-huh.
So it'd be
it is iron 3. So let me write 2 irons, because this 2 is saying that there's 2 of those. And then there's 3 oxides, and I know what the charge on oxide is because that's always the same. So they have to match. This has to be +6. So it must be iron 3 oxide. But I liked what he was saying about you have to state the charge because it's in the, there's more than one possibility. This is iron 3 oxide. So this is lead, and it's a lead oxide, but I don't know which lead oxide. What are my choices for lead?
2 and 4.
Mm-hmm. How do I know which one this is?
I would say that it's lead 4 oxide. In order to get the 2 charge on the oxygen, you have to multiply it by 2 because it has an original charge of 1. Or, oh wait, -2, I'm sorry.
Yeah, no, you're right though, it's lead 4 oxide. And these are our Roman numerals. 1, 2, 3. 1 less than 5 is 4. 5. 1 more than 5 is 6. FLUORIDE. Sometimes people misspell fluorine and fluoride because it looks wrong. And if you watch Breaking Bad in the first season, they spelled it wrong. Hydrofluoric acid. Ugh, I almost couldn't keep watching. Okay, are those right?
The top one's wrong.
What's wrong with it?
It needs a 2.
Oh, I was gonna be sassy and put it behind the sulfide, but it's late, I won't do that.
No.
So this isn't magnesium 2 fluoride?
No.
But what about that 2? Unrelated.
Yeah, I don't care about that.
But it's an alkali metal ion. What about that 2? It's always 2 or 0. There aren't other charge choices. Okay. Good. So how did we do? How many of you got 20 out of 20? Courtney and I are going to stay and talk about weighted averages, if anybody wants to stay with us. But if you don't, you're free to go. Bye-bye.